Okay, so here's the underside of my Montgomery Wards 1938 farm radio. It's a 6 volt powered radio. It uses a mechanical vibrator to chop the 6 volt battery DC to basically run a transformer and get high voltage AC, and then it has some contacts in it to um, rectify that power. Before I, of course, dared to start the thing up, I replaced all the capacitors that were paper wax capacitors. There's a few mica capacitors in there, but they almost never go bad, so I haven't worried about those. I didn't even bother to check to see if the capacitors were any good or not. Almost certainly, this era of radio, this old electronics, you can pretty much guarantee that they're no good. And of course, you try and start this radio with the bad capacitor, and you just take out a whole bunch of other stuff. And it's a pretty neat little design. I think I paid $32 for it. I was kind of hee-hawing whether or not I really wanted to get into. I've always into old antique radios, and my partner was nice enough to. He just decided he was just going to go buy the thing. Is he? Yeah, I don't know. I think he just liked the box, the cabinet. I guess I'll have to get the cabinet out sometime and show it. But it's a really nice cabinet too. It's a nice little radio. It has a magic eye station signal indicator. The biggest problem was the vibrator here. The contacts on it were probably welded, and I finally had to cut the can open in order to sand the contacts and get the thing going again. It just would not start. You could see all the filaments lit and everything. You can see how I kind of banged it on against something to try and get the contacts to jar and move, and it just wouldn't. And so that's probably the biggest limitation of these old radios, is the that are these 6 volt farm radios, is the vibrator. So one of my next projects was I bought this little electronics kit that's supposed to electronically chop the power and basically replace the vibrator. It's just probably a couple FETs here, and I wish the guy who'd come up with the design had done a little bit more of a nice explanation on how his circuit works. Unfortunately, his instructions are not all that good, and hopefully I got it all assembled right. There's a number of variations as to if it's chassis positive ground or negative ground. This is a positive chassis ground, so it's kind of it's definitely not what I'm used to. So the idea here is I'm going to take and replace the mechanical vibrator here. This nice little solid state bit of electronics here. Got some little straps here. Got a bin down there. Added some extra heatsink to them. But being I'm really into 3D printing, of course I had a 3D print a nice case for it. It more or less mimics the original case. It got some nice threads on it. Mount the electronics on the inside here. I believe I'm supposed to go this way with this. Mount that on with those straps anyhow. Got some brass pins I cut and machined, and I've got to solder up all the other wires yet. The threads go on pretty nice for 3D printing. It goes on pretty well. Obviously I got the screw on backwards, but it goes on there pretty well. This will just socket in the same location as the old one. And then hopefully I won't have that little extra bit of noise, electrical and audio, from the vibrator, and I won't have the starting problems, not to mention the fact that good luck finding more of these vibrators. I guess there might be somebody that's actually making replacement vibrators. I don't know. I think they're solid state. I don't think they're actual mechanical ones. Or at least I think I've seen them on the internet. And I don't think they're probably wanting too much, but this little kit was very inexpensive, and it's from the same outfit that I bought the capacitors. Ironically, I could buy capacitors back in the day at your local electronics parts store, and they just don't exist anymore, so I had to mail order it. So I was mail ordering it. I thought I'd give this little kit a try, so I just haven't dared to try plugging in the kit yet. So here's the radio. It's one of those things that's been a bit of a bench queen. I've got the thing, I think, mid last summer, and it's let's see here. Okay, well, I've already gone through a summer, so I guess it's 1.5 years now that's been sitting around. So I've gotten somewheres on it, and it does run. I'll have to hook it up sometime. It does have a bit of a hum to it. I've looked at it, and you know, you go from where it's supposed to be basically 110 volts AC, or DC, I guess it'd be DC, after it's been rectified. And the voltages are surprisingly good. I mean, consider how crude this thing is, that they have even anything remotely that good a voltage, and that low electrical noise is surprisingly high, but I still have a hum, and I don't think it's coming from the power supply section. At least it doesn't seem to match up with the on the oscilloscope. And unfortunately, the oscilloscope I got is a pretty old little parallel port attachment 2-channel thing that was pretty cool in 1999, but I'd like to maybe get a little nicer 2 or 4-channel modern scope, and then maybe kind of delve down to whether or not it's maybe the power supply or if it's somewhere else. My suspicion is that might still have something else going on. Of course, that may just go beyond my skills on this, but we'll keep playing with it. Another toy.